Alright, topic 17 is on perpendicular bisectors. One of the reasons why it made my list of 20 topics to know about is because it unites two mathematical words that you should be very familiar with. Perpendicular, which means that 90-degree angles are being formed, and bisectors, which mean that midpoints are being formed. Here's a construction of a perpendicular bisector, and since the compass lines were drawn the way they were, or the compass marks, it's split AB into two pieces that are congruent, and also split it at 90-degree angles. And you'd know that by just looks alone. And this question here, this is a question off the exam. They want to know the one that's not always true. Well, the segments are perpendicular. They do split into two equal pieces. Now this last one is deciding between the last two. This last decision that you have to make between these last two choices here is maybe not as easy to do. As it turns out, choice 4 happens to be true. Let me explain very briefly why. In green, these two segments have to be identical because they're formed by a compass. The compass was opened up and created this arc, or the circle that goes around. It's a pretty poor circle that goes around point A. Both green segments happen to be radiuses of the same circle, so those two sides are identical to each other. These two triangles are congruent to each other because of hypotenuse leg. So because of hypotenuse leg, these two triangles are congruent to each other, and that forces these two sides to be identical to each other. We're looking for the one that's not true. It would not be that choice. And you probably didn't even need to know all that information. All you needed to do is maybe take a look at the picture and judge for yourself that 2 would be the one that happens to be the lie, the one that's not true. If you look at just the picture alone, from A to B, you could even measure it with a piece of paper or a ruler. From A to B, I would doubt in this particular picture that that is the same as from C to D. And I didn't even measure it. I'm just saying based on looks alone, if you actually had a ruler, you could actually decide for yourself by measuring, is AB the same as CD? It should not be the same. Alright, this next question is on perpendicular bisectors as well. This one, they want the equation of the perpendicular bisector. They're giving me a segment that's determined by those two endpoints. They're not giving me a sheet of graph paper next to this question. You have to be really prepared. Every time you see a question involving coordinates, you're going to go to the last page of the paper, of the test paper, and find that scrap sheet of graph paper to sketch this out. So point A was at 0, 0. Point B was at 0, 6. So don't go left or right, just go up 6. 1, 2, 3, 4, 5, 6. This is a really simple question to do that a lot of students will not do because they get intimidated by the way the question's worded. I bet plenty of students will guess at the solution. They won't even try to work it out by hand. But if you sketched it out, and if you just take a deep breath and realize that perpendicular bisectors do two things. They bisect, which means they cut, and they cut perpendicularly. So they'd be forming a right angle there with that blue segment. What's the equation of that red line? Well, it's certainly not y equals 0 or x equals 0. It's down to those last two choices. Don't get confused on this. Y equations that are y equals a number always go left to right. And that seems to betray the idea of what that the y-axis goes up and down. But another name for the y-axis is actually x equals 0. So a horizontal line will always begin with y equals and then whatever number it's passing through. So choice 4 would be the right selection. Yeah, on this last question on perpendicular bisectors, they actually have you constructing a perpendicular bisector of AC. So let's plan that out first of all. AC is this blue segment here, and we want to create the perpendicular bisector. Well, what will that look like? Let's just plan it out in our minds. If it's going to be the perpendicular bisector, it would have to go through the midpoint of AC, and it would have to be forming a right angle with AC. So that's what it's going to look like when everything's said and done. Now I have to actually do it with the compass and a straight edge. So what would I do? I would actually open up my compass and put the point down here, the pointy end of the compass here. And I would open up my compass so that I make an arc that's more than halfway from A to C. So that's where I put my lead of my pencil, right there. More than halfway. And I would swing an arc in that manner like that. Then I'd switch points. Then I'd pick up the point of my compass and lay it here. And keeping my compass open to the same measure as before. I wouldn't change the angle of my compass. I would just switch to point C, and I would also arc it as well. Now I'm just doing that freehand. Let's see how well I did. The last thing you would do is connect these 2 points together, these intersection points, and that's how you would determine the perpendicular bisector. Hey, pretty good without a compass, just drawing it freehand. I'm probably off just a little bit, but you of course have to use the compass to do that. The chances of that showing up on the exam, a construction, is not an entirely great chance of showing on the exam. And for a question that might just be a 2-point question, kind of a sacrifice that might have to be made if you don't understand how to do all the constructions. That could cost you a few points on the exam, but not exactly a high priority question for this exam.